All right, guys, in this tutorial, we're gonna be training a model from TensorFlow, okay, to detect chili. Okay, so this is a very actually valuable skill to have because once you learn how to do it, you can train the model to detect whatever object that you actually want, and it will be working efficiently, okay, on a very high level because you know the models, okay, of TensorFlow are actually fast and powerful. So let's go ahead and start the process. All right, guys. So the first step in order to train the network, we need a set of images that contains the object that we're actually trying to detect. In our situation over here, we have uh, images of chili. Okay, at a minimum, you need 100 images, and you can go up to 1,000 or hundreds or tens of thousands, or even more than that. Okay, if you are a very professional level like Google or something. So in our situation over here, we have a bunch of images for chili. Okay, one mistake I've actually done, okay, when I've selected those images is that most of the images has got a white background, so the network would not function properly, on different backgrounds like trees or something like that. So initially we have a set of images, okay, to train this network on.
All right, guys. So right now, the next step, after we have gotten our set of images, we need to crop each image right around the object that you're trying to detect. So if the image contains, a lot of stuff, you need to crop the image right around that object that you're trying to detect. So in my case here, I have chili images. Okay, and right now, I need to crop each image right around the object that I'm actually trying to detect. And also in this process, I will be generating what we would call an XML file. This is a simple file that contains the coordinates of the cropped part of the image as well as the label, of that object, okay, that we want the network to produce in relationship to that object. So in order to do that, we will go to this link. It's right in the description. I'll put it in the description. Okay, so this code, called LabelImg, it does what I have actually talked about, before. Just simply, clone the code, install it, and you need to make sure that you have the following installed in your system. You need to have Python, you need to have this, pyqt5, and you also need to pip install LXML. Okay, so make sure you have those three. Okay, then go to the wherever you have actually installed the file. It will be called LabelImg master, and from here run it using Python. So from this folder I will start the command panel and I will run it using Python. It's called labelImg.py. Let's try this out if it works. All right, let's wait. I'll get back to you guys. All right, guys, so the folder here actually opened. Okay, so we need to go to the directory that we want to, where we have actually saved our images. Okay, so sorry. Okay, let's assume that we have saved our images in this train directory. So we select the folder. Okay, so this is what happens over here. Okay, now in order to label this image, we will hit create box over here, and then we will drag and drop around our image. Okay, and then we will select whatever label we want to assign to that image. Okay, so in some cases we have more than one object that we want to identify and detect using the neural network. So assign whatever label you want to this image. Let's assume it's chili and hit OK. Right, so in my case here, I've already labeled this image before. This is why we have chili twice here. It should not be, it should just be only once. And then you will save. Okay, and you will save it in the same place where actually where you have your images. Okay, and then you will hit save. Okay, excuse me, in my case I've already done that, so this is why it's already available, okay, in my folder. Okay, then after that you go for the next image. Okay, sorry, I already have it labeled, next image, and then you again drag and drop. Okay, drag and drop. Okay, and then you save, or you could just hit the next image and it will ask you to save, and go ahead and save it. And we will repeat this process right now, okay, for all the images that you have actually collected, okay, for the training process. So right now, okay, we have our images over here in this folder called images. Okay, it was the folder that contained our original images, and they're okay right now corresponding XML file. Okay, so each image here has its corresponding XML file. It's just a simple file that includes the information about the image, like its label and the coordinates of the cropped part of the image, indicating the object that we're trying to detect. So guys, what we're gonna do right now is we're gonna divide those images, copy around, let's say, 80% of them, okay, into a folder that we call train, which is going to be our training data, and the rest 20 or 10%, whatever you want, okay, into another file or folder, sorry, called the test data. So what we have right now, okay, is our training data, okay, right in this folder, and our test data right in this folder.
Alright guys, so the next step is to actually convert our XML data, okay, into the CSV, okay, format, where the CSV format is an Excel file that includes the information, okay, for all the images in one file, instead of the XML file includes the information for each image individually. So in our case over here, we have the XML to CSV code. If you go to my GitHub over here, I have uploaded for you, okay, for educational purposes, of course. Okay, so you can actually, okay, download it, okay, and place it in this okay, directory over here, the chili project. It should include the data, and it should also, okay, include the images, okay, folder. So right now I'm gonna start the CMD and run this code using Python, okay, and boom, and it has been converted, okay, successfully over here. So right now if you go to the data, okay, folder, you will have those two okay, you will have those, okay, two okay, files over here. As I told you, okay, the file includes the images for the information for all the images, okay, combined in one, okay, file. So you need, okay, to do this instruction for both the, yeah, that's it.
Alright guys, so right now the next thing we are going to do is to generate the TF records, okay? So the TF records is the final shape of the data which we're gonna need, okay, in order to train our model, okay? So what we need to do right now is to go to this link, I will also leave it in the description, and copy this code, okay, over here, okay? The next step is to generate the TF records, okay, from the data we have over here, which is the last step in data preparation for the training. Okay, so I want you to go to this GitHub link over here and get this code. Okay, copy it and create a py file. Now the final step in the data preparation is to generate the TF records. Okay, so I want you to go to this GitHub link over here and copy this file. Okay, now let's have a quick look at the py file over here. Now, there is just one simple modification which we need to do, is to put our own label, okay, for whatever object that we're actually trying to detect. Okay, in our case here, we are labeling chili. If you have more than one object which you're actually detecting, then just add more if then statements over here to this function. Okay, now, yeah. Now, one more thing before we are able to run this code. This code works within the TensorFlow object detection module. Okay, so, okay, if we look at here, from object detection.utilities, import this thing. So this is part of the TensorFlow object detection module. So before we can run this code, we need to install the TensorFlow object detection module. In order to install the TensorFlow object detection module, just go to this link. I'll also add it in the description, and download this. Please clone this directory, okay, over here. Now guys, I have actually downloaded the directory. Okay, it's called models master, and I've extracted it. Okay, and I just renamed it as models. Okay, now I want you to go to this directory, and I want you to go to the research. Okay, inside this directory we are going to be doing our work. So what I have done, okay, please focus with me over here. I have copied the data directory. I have copied the images directory. Okay, I've also copied the generate tf-record file over here, and I've also created a training directory. We're gonna need it for as we move forward. So inside the research directory, I have copied those folders. Now from this directory we can run the object detection the generate tf-record .py. Guys, so right now from this research directory, we want to run our tf-record generator, right? So we need to run this instruction twice, one to generate the train record and one to generate the test record. So let's copy this instruction over here. Guys, so after running both instructions, I will leave them in the description also. If you go to the data directory, which we have actually copied into the research directory, as I told you, you will find those two files, the test.record, the train record. Okay, to make sure that your TensorFlow object detection module works properly, please download this file over here, protalk.exe. In order to download it, please go to this link over here and select the version that's appropriate for your system. In my case, it's protalk Win32. Okay, and then please copy and paste the protalk file in this research directory. So once you run it, it will actually prepare the directory to work properly. So after you have downloaded this file and copied and pasted it in this research directory, just open the command prompt and copy this instruction over here, protalk object detection protalk. I will leave it also in the description, and run it. So let's just get this one out of the way.
All right, guys. So right now we have the train record and the test record. Okay, the remaining two things needed are the configuration file and the model itself. So let's first download the model. If you go to this link over here, and plug it into your browser, it will start the download automatically. Over here, and it will download this model over here. So once you have extracted the model, okay, twice probably to get this folder over here. You need to copy and paste this okay folder into your research directory. It is where all your work is happening. Okay. All right, guys. The last thing we need here is the configuration file that contains the setting for the training process. Okay. So if you go to my GitHub over here, I have this file. Okay, for this tutorial purposes. It's not my own code. Okay, as a disclaimer. Okay, so okay, what you can do, okay, is copy this, okay, raw code and paste it into a text file, and then okay, I want you to call that file .config. Okay, in my case this is my file. Okay, over here, if I show you the extension for it, okay, it's .config. Okay, so get that code and save it, okay, as a .config, okay, file. Now let's have a look, a quick look at this code, okay, and what we have actually modified inside it. Okay, we have the number of classes. Okay, in our case it's just one class. Okay, it's just chili. We have also made some okay modifications over here. This is the path, okay, to the model, okay, which I have just okay downloaded. Remember the directory I have just copied into the research directory. This is the directory that contains the model. So this is the path, okay, to the model. This is also the path to a file that we will create soon. Okay, it's the file that contains the labels. Okay, so we will create this soon. It's going to be inside the data directory which we have created before. This is also the path to the train record, okay, inside the data. Okay, and finally this is the okay path, okay, to the folder inside, okay, another copy of this file, okay, inside a directory that's called training, which we will create soon. Okay, so this okay training directory, okay, will include the checkpoints, okay, and the documentation of the training process. So we will create it soon. The next step is we will create this training okay directory. Okay, and inside this training okay directory, we will create this okay object okay detection okay file, okay, we have referenced before. Okay, and it will include the item ID and name. Okay, so in our case we just have one class. It's going to be chili and its number is actually 1. If you have more, you can add them okay in this list over here. Okay, now you have created it. Okay, just remember you should put it in the following extension. Okay, it's gonna be .pb text. Okay, now I want you to create another copy okay of this file over here and put it in the data okay directory. Okay, it's gonna be also available over here. Okay, let's recap. Okay, what we have over here, we have right now the full kit for training. Okay, remember to have all those placed in this okay directory, in this research directory. It's kind of like our RAM. Okay, it's okay where all the work is actually okay happening. So we have the model folder which we have just downloaded. Okay, we have the training directory. We have the data okay directory okay over here. Forget about the rest, it's just part of the TensorFlow okay package. We don't care about it right now. Okay, but what we have pasted over here, the data. Okay, we also have the images directory. We have a look. Okay, the test and train and all the images. Okay, and all right. Okay, and we also okay have the what we have here. Okay, we have the model directory and we have the training okay directory. Okay, so this is kind of like the okay, this is kind of like the toolkit that we need to make the training process. Okay, right now, one more thing that we should actually have in this okay folder over here is this train.py folder, sorry, file. Now if you just install this models directory from TensorFlow, it's not going to be available over here. Okay, it's going to be somewhere inside, those kind of like directories over here. So just if you research it and hit, okay, train.py, you will find it somewhere, and you need to copy and paste it, okay, over here, because it will include paths that will only be able to work from this, okay, directory. Okay, so copy and paste it into this, okay, directory over here. So let's do the training process right now. We're gonna copy this instruction, okay, over here. Okay, and we will go to our working directory. All right, it's the research directory, and we will hit cmd from here and start the cmd from here inside this directory, and we will, okay, paste this instruction. Okay, now the first error I've encountered, no module name tfslim, so I went away and pip installed it. Okay, so if you face the same problem, you just pip install this one. I'm out of my mind. All right, so right now, okay, we are in the command, okay, prompt over here. So I will, okay, copy this command. Okay, actually it will start this Python file, run it, okay, using Python. Okay, and it will specify the training directory. It's where all the checkpoints are going to be saved. Okay, and it will also specify the model to work on, okay, over here, and the configuration file, okay, path, okay, over here. So let's go ahead and copy and paste this one, and boom, and here we go. um, the training starts. But please don't close the video. There's a very, very important thing that I have to, okay, um, to mention, okay, over here. I will leave it training so you can see how the training actually happens. A lot of stuff are going on right now. It's a huge, huge, okay, pieces, okay, of a system coming together in one place. So before you go ahead and start, okay, the training process, or try to initialize the training process, there is something that I should actually tell you. I have actually, until I was able to successfully launch the training, I had to actually try about, maybe, as you can see, about 10 times until it will actually, okay, work with me. So here's what I had actually to do before I was able to successfully, okay, initialize the training process. Okay, I had to pip install this directory. I don't know how to skypy or skipy or something. I don't know how to pronounce that. I had also to pip install tensorflow.io. Okay, I had to pip install, okay, matplotlib. Okay, I had to pip install YAML, if I'm pronouncing that right. I had to pip install gen config. Okay, so do that if you need. I had to pip install TensorFlow, okay, dash add-ons. Okay, I had to downgrade to TensorFlow 1.15. Okay, okay, because the model I'm training does not support 2.7, which was my version. Okay, and there is one last problem also I have faced that actually took me a couple of hours to figure out. So I'll give it to you really, really fast over here. If you want to make the training right on your, okay, laptop, you don't want to go through the cloud computing. You just have, kind of like 100 images, and you just want to do it overnight. That's going to be possible. You don't have to go through cloud computing. So one last thing, I had to install an equivalent version of TensorFlow 1.15 because the original version from TensorFlow did not work with my current CPU. So my CPU is actually Celeron, okay? So I was actually, okay, getting this error, okay, over here. I was getting this kind of error. I'll show it to you right now. Okay, so if you have i5 or something, it's not going to be a problem for you. I was getting this kind of error, couldn't load or failed to load the native TensorFlow runtime. Okay, whenever I try to import TensorFlow. Okay, so if you face this kind of error because you have a certain CPU, okay, when I use it on an i5 machine, that did not happen. Okay, so, but on this, okay, Celeron, okay, processor machine, I faced this problem. So what you will do is you will actually install this, okay, kind of like equivalent version of TensorFlow. They call it wheel or something like that. Okay, so you're gonna have to download this file and then run this command. Okay, over here. Okay, so I hope this is clear. Okay, let me kind of like try to add this link for you. So another problem where you're gonna face the error unable to find a module or module not found is not when you are calling a package that should be kind of pip install on your system. It's gonna be when the code is calling modules and functions from within the TensorFlow module. Okay, over here. Okay, so the reason for that is going to be a path issue. So what you should do in this situation is the following. Okay, you should copy this instruction. Okay, copy Python path, etc. Okay, and run it inside your research directory or your RAM directory. Okay, in general over here. So you're gonna start the command from over here and copy and paste this instruction. Now, if this did not work for you for whatever reason, just simply search for that module, that directory which your code is unable to find. Okay, and you're gonna find it within those directories. Okay, just copy and paste it. Okay, here in this research directory over here, so the code is gonna be able to see it. Okay, that's it. Those are the two problems that I've actually faced. Okay, during my trials to launch the training process. It's either modules not found because they should be pip installed on your system, or modules not found because the path towards those modules within my TensorFlow directories was not actually clear. Okay, now in order to run the model, okay, and perform the object detection process, okay, we need a code that is within the TensorFlow module you have actually installed, okay, from GitHub, okay, called object detection tutorial. Okay, generally it's called object detection tutorial. This is my own modification. So first, you're gonna have to go and search for this code. Just write it in the search box and find it. It's gonna be somewhere, okay, within the TensorFlow, okay, directories. Okay, so copy and paste it again in the research, okay, directory. It's your RAM directory. Okay, now I had, in order to make this code work on my own model, I had to make the following modification, okay, over here. Now this is the code after I have actually modified it, and this is the code before modification. This is how it comes from TensorFlow. Okay, so in this situation, it works on a model that it downloads, okay, from TensorFlow. So we want this, okay, code right now to work on our own, okay, model. Okay, so what I've actually, okay, done here is I have changed the base URL from this download, okay, link over here, to where the model is actually, okay, placed, okay, in my system, which is the research, okay, directory. So copy and paste the link towards your research, okay, directory on your computer. Okay, now this is the same. This is one also the same. This is also the same. One, okay, more modification is the model directory. Okay, it's gonna be the name of the directory to which you have actually exported your model. Okay, in my situation, it's the Chili inference graph, the name of the directory. Okay, it's inside the research directory. So you're gonna have to get rid of this, okay, one. Okay, now the rest, okay, is all actually the same. In order to generate the model, so right now we have, okay, performed the training, and okay, and right now if you go to the training directory, okay, over here, okay, you will find all the checkpoints, okay, for different versions of the model during its evolution. Okay, so the way the code works is every time it reaches a certain, point, it just saves the checkpoints and the data for that model. So right now, you can go ahead to the training directory and select whatever point of training, okay, that you want. Okay, so usually you will select the last point or something like that. Each point has got three files: index, meta, and data. Okay, and it will actually have this number, okay, that represents the number of this check point of the model. So this is the number that you're gonna use to distinguish what point of the training you want to export the model for, in order to be able to evaluate that model later. So what you're gonna do next is the following. We have this, we have this instruction over here. I'm gonna go through it right now. I'm gonna put it in the description also. Okay, now we're gonna run this export inference graph.py. Now just find it somewhere in the directories, copy and paste it in your research directory, in your run directory if you want, okay, in order to avoid the kind of like path issues. Okay, right, okay, so here is what we have over here. This is the path for the configuration file we have actually created and placed in the training directory. So it's in the training directory, okay, and this is the configuration file that we need to actually include. Now also this is the path right now to the model checkpoint. In my case, this is the number of my desired checkpoint over here. In your case, it's going to be different. It's also in the training directory. And one last thing, you will actually decide the name of the output directory that will include the generated model. Okay, so the output directory, in my case, I called it Chili Inference Graph. It will actually create it for you, okay, once you run this instruction. So right now, you're going to copy this whole instruction, okay, and go to your research directory, okay, run the command prompt and and paste it, okay, and hit enter, and then it will actually create the, let me show you this folder over here, the Chili inference graph, which you have actually generated right now out of this instruction, and it will include the saved model over here. Okay, so those are the three files included, and this is the frozen inference graph, and this is the saved model, and etc. Okay, so this instruction generates the model that you actually can use to evaluate and perform the detection process. All right, so again, let's run the model. Let's just write the py. Okay, so Python object detection tutorial, Chili, and right now the model is running. Now it takes time to initialize, but once it initializes, the processing for each image is very, very fast, okay, and efficient. You can even, detect in real time on a very, very simple machine. All right, guys, here are some results. Let's get back here. Okay, it's actually detecting nicely some of those chilies. Still need much more training. I think one of the problems is that we made most of the images on a white background, so it's not working nicely on kind of different backgrounds like trees or something like that. But it's kind of detecting the chili nicely, so it's failing badly on different backgrounds. Yeah. We only used 100 images, which is very low for those kind of networks. Okay, so those are the results that we've actually got over here. So on different backgrounds like trees or something, it's not really doing a good job over here. Okay, I think this is due to the background, so we should include this also. Okay, we should include multiple backgrounds, not just white images.